studies. Okay, we're going to go ahead and get started. Can everyone hear me okay?
Yep.
Okay. Well, the information provided is for educational purposes and is not intended as medical advice or a substitute for medical advice of a physician or other qualified healthcare professional. We do not aim to diagnose, treat, cure, or prevent any illness or disease. And you should always consult with a doctor or a healthcare professional for medical advice or information about diagnosis and treatment. And this information has not been evaluated by the Food and Drug Administration or any other medical body. Good morning, good afternoon, good evening, wherever you are in the world. This is Dr. Dori Narbo. And for those of you who don't know me, I am a clinical researcher and an author of several books. So welcome to our call, our Tuesday call with Clayton Thomas, who is the founder of Root. And Clayton has over 25 years of experience in the health and wellness industry. And for the past 16 years, he's been focused on detoxification and supplementation formulations with a simple philosophy: cure the cause. Well, welcome to the call. I mean, how many calls have we done now? Close to 80, 90?
Good Lord. I mean, when we go back and look, it's probably
almost 90, I think.
Probably, yeah. I know we're into the 80s. I mean, you think of that, it's over 80 hours of content that you guys, well, more than 80 hours, over 100 hours of content that you guys have edited.
Today, we're going to talk about Clean Slate and comparison to other products, but we're not going to name names. But first,
when you say we won't name names, you might not, but well, I have a reluctance to not protect the guilty.
So last week we talked about barium, which is the philosopher's stone, discovered in the early 1600s, and it was discovered because at night it gives off this bluish light, as you can see here. But this is an example of what they saw. Imagine how incredible that must have been to see something like that. So this is actually augmented with UV light. Barium sulfate, this is something that's used in the petroleum industry for drilling and for oil and gas wells as well. It's also used for glass making and creating rubber. And then it's also, this is barium carbonate for rat poison. And then we have in everyday life, we are using barium for ceramic glazing, paints and makeup, optical, glass and bricks. Of course, you'll find it also in your fluorescent lighting. And then of course, in analytical chemistry, it's used also in fireworks for the green and the red colors, and also used as ammunition tracing, and also for thermic welding. Okay, so barium fluoride is actually used for X-rays, gamma rays, PET scans, and it also has levitation properties as well, which is actually pretty cool. And it's also used for bilirubin testing, and also found in tattoo inks. Actually in Italy, 56 tattoo inks was found. Barium was found in the inks. And of course, we all know it for the X-rays, for the barium meals, the barium enemas, and things like that. So, and it is a common pollutant in urban air. And it's also in food. So we, it just goes to show that we just can't get rid of heavy metals. It's in the air, it's in the food, it's in the soil, it's everywhere. So Clayton, this is, you're up next. So we're going to go ahead and I thought maybe we'd start with this slide here so that people can actually understand the sizes, because when you start going into these particle size and things like that, I think they kind of need an overview of what this means.
Yeah, so I mean, this is the one key thing, like you're talking about, is you hear people use terminology, but if you don't have a reference, you only hear hype, right? So the important thing to look at is when you hear people talking about being 1 nanometer in size or a couple nanometers in size, and what nanotechnology is look at you can see the comparisons from what a single carbon nanotube looks like around 3 to 5 nanometers in size, and where a full virus is around 80 to 100 nanometers in size, and where animal cells and red blood cells and bacteria and such are in the micron range. So when you hear companies talking about the size and fragment size and such, what you actually want is a broad range of fragments, and really in any process, especially dealing with a natural substance, and not synthesizing a natural substance to create specific molecules like you do on the bottom here with transistors and carbon nanotubes and crystal and lattices, which are components that are used in nanotechnology and bioscience engineering. I can say that I've seen these conversations because this is some of the stuff Christina was going over in her classes on nanotechnology and bioscience engineering at Harvard, right? And true nanotechnology is where you see those things used. So while we're going to look at some fragments that are really small, if you have a company claiming to be like super nano, which there are a couple of the zeolite selling MLM companies that do, you can get a pretty good idea that they're probably not telling the truth. And we're going to see some of that because they haven't even done their own analytical chemistry or scanning electron microscopy to analyze their fragment sizes to know the exact conversation that they're making, and they're incorrect. And when you hear our conversations, what we really want, and I believe I sent some of the data to Dory initially, is when Christina was creating what Clean Slate is we wanted the most broad fragment range possible. The initial solution ranged actually from 1 micron. So just the line above the 100 nanometers where you start to see the animal cells. And so 1 micron over 100 microns. But we made some advancements in the production process to actually broaden the fragment range. So to go not just small, but larger than 100 microns, because there's great advantage in having this breadth of different particle sizes and fragment sizes to work through different areas of the body. So use this as an example, especially when we look at the viral aspect, right? If you're dealing with a virus or viral fragments that are 180 between 10 and 100 nanometers, you don't want something a lot smaller than that. You want something bigger, or you want something that can work with it in different ways. So,
Okay.
Step 1.
Okay, so maybe you might like to explain this slide.
Oh, we're getting right into the blood work. So what you see here, and because of the backgrounds that I have and that Christina has, and I was talking with a couple people about this. I remember being like 7 to 8 years old and being in the clinic. I was in the lab with my mom, and I'd be able to play on the microscope, and we'd get blood and fecal samples from cats and dogs, and you get to look at microbes and parasites under the microscope, and you look at red blood cells and how they're performing. And this has always been something that intrigues me greatly, right? To see how things are functioning. But what you see here is fireworks that I've never seen before, and the doctor that was doing the live blood cell analysis had never seen before. So what this image is taking a drop of blood, which you can see kind of on the bottom left, and taking a drop of the fragments and putting them on a slide and letting them come together. And what you see in the middle, all of these bright lights and colors, is actually the point of connection when the fragments and blood come together. It's like fireworks taking place. It's really cool. But it's not something I've seen before, but you can see what happens from an energetic perspective when these come into contact the first time. And we'll look at how the blood can shift a little bit, probably here in a minute. So this is looking at one of the fragments under dark field microscopy and pretty high level magnification. I think it's like 3,000 or 5,000 times magnification on a scanning electron microscope. And what I really found interesting is not just the porous structure of what that little fragment looks like, but the color, right? Is when you look at your aura and the energy coming off of our aura, you want blues and greens. And you can see that these little guys glow the same colors as an ideal aura. And you can also translate, then you can look to translate what you're seeing in this energetically to what Dr. Stefan Rao has found in his heart rate variability analysis of watching the energetic shifts in the body and how your aura can actually increase rather quickly because you're taking the energy from these fragments and the communication that they have with the body and actually enhancing your overall bodily function. These are additional shots of the fragments. But what's really interesting in this is look at how they're aligned, right? And the polarization of these crystal fragments is one thing that we talk a little bit about, and I don't think we talk enough about. And you have these little balls, and you can see up top where you get a better example of it, you can see that blue green, and they're a little more clear. But because of the polarization process that they go through, they actually space themselves. They repel one another because they're all negatively charged, right? So if you have a bunch of negatively charged magnets and you have no positively charged magnets, and you try to take two negatively charged magnets and push them together, they will repel themselves, right? They create their space, right? So you see these fragments doing the same thing because of the polarization and their energetic potential and all being negatively charged, they all create their own space. And we'll see that in some of the newer imagery that we got from Birdie, is how a larger fragment can actually repel some of the smaller ones. And you can see some of the same spacing. It's just unique, and how these little guys will space themselves out and look like this little militia of blue-green greatness.
It's amazing.
They're kind of cool.
Yeah.
And it's kind of cool to think that you're taking these little guys, and this is what you're putting into your mouth and into your body. You've got these little glowing balls of detoxifying greatness, but also silica delivering, which we'll probably hit on a little bit too.
Mm-hmm.
There's more.
Okay.
Oh, and I think this is one that Sasha Stone got really excited over, and I think is highly prevalent right now because of the vaccine environment. I actually just got a video from one of our ambassadors that's doing some dark field microscopy on live blood, and he just, let me see if I look at the notes. He just took a video of someone that I think was vaccinated like 2 days ago, and he was seeing microbes and stuff that are floating around in the blood and that are attacking blood as their blood starts to look like what you see on the left, that your red blood cells become coined, and this is called stacking, right? This is what blood clots come from. It is not healthy. This is a 38-year-old female smoker. Both of these images are from a 38-year-old female smoker. The difference between these two is 10 minutes and 10 drops. That is all. Same person, same blood, drawn 10 minutes apart after taking 10 initial drops. That kind of phase shift is not something that happens physically. This is what speaks to the energetic aspect of what these little fragments are doing in your body, that they're causing things to start happening much quicker than just taking something physical. And that's where the question just comes about how does clinoptololite prevent stacking? It's the detoxification of cells, but it's also the energetic aspect of recharging them and helping them become healthier. We could we could talk for 2 to 3 hours just on this aspect of coining and what happens with intracellular water. And this is why it's also important and why we recommend that you have to drink more water, because when your cells look like they do on the left, they've lost a lot of their intracellular water, and intracellular water is the key to cellular vitality, right? It is crucial. What you see on the right after 10 minutes is those cells uptaking a lot of water, and as you can see around them, they start to glow again. They look healthy. They're moving around one another. So and this was before we added the trace minerals. Oh, and we get images. Here we go. So these are scanning electron microscope images of the fragments of all different sizes. So when you see the times 3,000 and times 4,000 and times 6,000, that's the times magnification of the microscope. So it's using 3,000 times magnification, or where we got 4,000, 6,000, and 6,000 times magnification. And then you can see the little bars on next to the magnification, which is your measurement bar for the size reference, going back to what we were talking about with microns and nanometers, right? So you can take that little bar and you can visually kind of compare that to what you see some of these fragments, but you can see that they're not smooth, right? They're very porous, right? They have all of these binding sites on them, and they're all different sizes, right? There's nothing that is standard to say everything is going to be in this range, because that is impossible, right? And so you have this vast array of lots of little crystalline fragments that are able to do what they do really, really well. And they're kind of cool to look at. Mm-hmm. I wish we had this when I was growing up for a science project, because I would have crushed it.
Okay, next.
What else we got for the next one?
Yes, we'll start from the beginning now.
Okay, so we got to do the side by side. So these are looking at comparisons of 3 different products of the Cosiva Clear TRS product, Zoe Global's, I think they call it Clear Drops, and Touchstone PBX. Or their newest product. So they're all zeolite products that all claimed basically to do about the same thing. What we're going to look at is these 3 different products. I know one of them has the name on it because I was able to figure out which one that is, but then others are unnamed, as we'll see with product A. So what we want to look at is comparative analysis of. We can get an idea for fragment size, because on the left, and you can't see it as well on the right side. But I want you to look at 2 things in these images that we're going to look at, because we're going to do as best we can do for side by side comparative analysis of images, right? So 3 things to look at. One, you can see the size references that are on these. You can see that there's 46.6 and 43.7 as far as size reference. But also look at the concentration of fragments that are on the screen when you're looking at them. And then the third is the size reference on the bottom for what magnification and what type of analysis, because we want to make sure that we're comparing side by side analysis, right? So this was one of the products. I'm not going to guess at which one it is, because we know 1 out of the 3, but this is 1 of 2 that wasn't named. So we will protect the guilty. But you can just remember on the left, when you're looking at the one micron here, look at the number of fragments that you see on the screen. That's going to be an important frame of reference. Next.
Okay.
And then product B. So if we could, you can see similar, right? 43, 49, 37.9 on the right side, because this is the one micron analysis for product B. And like, Dory, go back to product A if you can, skip back.
Mm-hmm. Again? No, right here.
Yeah. So look at the comparison of the number of fragments on that screen right? Because the same amount of solution in each for each product on each slide. So what this is a direct comparative analysis of the same amount of solution. So one of the things that's most important, and you don't hear people talking about this, is, okay, what is the concentration of the ingredients that are in the solution that you're taking, right? That's important. So go ahead, go to the next one. I think we'll get to C here. You look at this image on the left. There's 247, 113, 107, 43.7. But notice that there's not a lot there, right? There's a lot of space, a lot of surface area in between those fragments that there's just not a lot on the slide. And when you look over on the right at 500, the 500 nanometers, it's the same thing. There's just not a lot there. So what does that tell you? Well, there's a lot of water and not a lot of what you would call actives, because the only thing that the Cosiva TRS product and the Touchstone product claim is that the only thing that they have in their product is clinoptilolite fragments or synthetic zeolite fragments. And you can see if that's the case, well, where are they? Because the product's not preserved, which you're not going to see preservatives show up, but there's nothing else there. So it brings into question what you're paying for, because there's not a lot there. So go forward. You're going to surprise me with what the next slide is. Here we go. Now we get into the good stuff. So go forward one more, because you're probably going to show me. And you can see when these were done. These were done on so these are pretty recent. It is September 21st. So go forward one more. Actually, yeah. So here's one in 500. Can you go back one real quick? Because I want to show everybody the reference that we're talking about. So remember when we were looking at the blue-green photos, and you can see this little dude in the middle here on the bottom, on the right side. The big one is 711 nanometers, and the big one up top is 559 nanometers. But notice energetically, they're larger, and that they actually repel all of the other smaller fragments from coming into their space.
Yeah,
right. And you see all the little guys spacing themselves, but you got those big boys of like, no, I'm here. Just stay away from me because I've got more energy than you do. So you see that spacing. Now go forward one slide. So this is the comparative analysis between those three other products, right? And it's so cool when you look on the left that you have another one of those large fragments amongst the smaller fragments. But notice, even with the smaller fragments, look at the amount of fragments that you see all through that image. There's hardly any space because of how they're spaced. And then when you look at the right, you can see the fragment range on there of 18, 21, 42, 43, 59, 36, 24, 13, all these different fragment ranges, but you can also just look at the sheer concentration of fragments that are there. But when I got the image initially of the one on the left, and you just see that one big dude that sits there and it just pushes everybody else away from it. And you'd think, oh, well, that's bad because there's no fragments there. It's like, no, you have to understand, because these fragments are polarized, they perform differently. And energetically, they're so strong, they're actually repelling the rest of the negatively charged fragments from their space. So it's so cool. I love that.
It's really interesting because you have all the different sizes.
Yeah, and it's funny because we don't talk about the fragment size much. Everybody else promotes, the size is everything, and they're different. They're made different. They look different, and they get outcomes, which is what is really the most important. Now, this is kind of cool, right? So this one millimeter of the bake. Just look at that structure, though. It's just kind of cool. And same thing. So that's what the dried drop of Clean Slate looked like on the slide when it dried up and crystallized. There's lots of comments in German, and I'm not going to be able to get in those. So same.
Okay.
So you can see. Oh, go back real quick. So product B prior to imaging, and you can see Clean Slate prior to imaging. Do you see any difference in content, right? She took the same amount of drops to put on there, but just look at how much content is left on the Clean Slate side versus the product B image. And she used the same amount, right? Same amount of drops to put on there. That was one thing that I made sure she was doing so she could have really good analysis. And
well, it kind of, if you think about it, kind of makes sense because if she's baking it and it's mostly water, I mean, that's going to be gone.
it's going to go away. Yep.
Nothing there. Okay.
And here comes the fun. Can you zoom in on that a little bit? Or
I don't know. No.
Okay. So what's important, I made sure Dory had this because we talk about this, and this is the COA of our raw, right? And what's so crucial, if you can, under the vendor specifications.
Oh yeah, right here. I saw this. This is really nice. Yeah.
So what we start with is 97% pure clinoptilolite, and this is the COA on our raw clinoptilolite. And this, you want the secret sauce that makes this so special. Here you go. And what do you want to look at this? Well, 97% pure clino.
Yep.
But then when you come down here, you see sodium aluminosilicate, 97% plus clinoptilolite. But then when we come down here to the typical chemical analysis, and you see the first one, right? And this is what's so crucial, is what is the makeup of this crystal? Because not all clinoptilolite is the same, right? And if you're going to process something, if you're going to take a crystal like clinoptilolite and you're going to break it apart, you no longer have clinoptilolite, because based on breaking it up, you've changed its structure. What you then have is the constituency of what you've broken up. And that's going to be predicated on what this is made of. And it's also why using a synthetic, like they use in the clear TRS product from Cosiva, is so horrible and never recommended for human consumption, is because it is a synthetic aluminosilicate. And when you break that apart, you have a freeing up of a lot of aluminum, right? And it's scientifically proven that synthetic aluminosilicates will actually denature an acid, unlike natural occurring zeolites. So when you put them in stomach acid, the aluminum will release and create more aluminum toxicity. But when you look at our raw, the largest concentration, 66.7% of our clinoptilolite that we sole source and is proprietary, and no one else can get our source, which is really, really important. 66.7% is silica. So why do we talk about bioavailable silica and orthosilicic acid and silicon dioxide on the labels in Europe, which are going to be on the labels in the US? It's because 66% of the clinoptilolite that we start with is silica. And then when we process it, when we break it apart, we're freeing up a massive amount of that bioavailable silica. So that is why we have the language, we use the language that we do. Let me see here. So this is a letter from our manufacturing partners that I asked, because Christina gets questioned, and there's so many questions on process, right? Because I've been in this space for 16 years. I have to give a shout out to Harv Kaufman. Harv was the guy that really started this liquid space, and Harv worked originally in the tire industry and read some of the literature on clinoptilolite that showed that this amazing crystal had the ability to upregulate tumor suppressor genes in cancer cells. It was activating P21 and P27, and causing cancer cells to die and go through apoptosis naturally. This is all published, it's proven, it's on PubMed. And Harv set out to create a process that he devised, because I think of what they were doing in the tire industry, but he devised a process to take a bunch of acid and basically dissolve clinoptilolite in his way to break apart the cage structure, break some of those bonds of that honeycomb cage that we know clinoptilolite is made from, and use an acid to do that process. He was the first guy to do it. And it was through his process that I was introduced to this industry with Wayora, because they were buying product from the company he had consulted with initially. And then that's where this whole journey of all these zeolite products came from. Rick that had created this after I left Wayora long ago, like 15, 14 years ago. I was working with Harv and that team to improve their process, because it is very, very rudimentary. Processes on both sides that are identical. They take a pot, 5-gallon pot, and a hot plate, throw in some clinoptilolite powder, some water, some phosphoric acid, heat it up to about 400 degrees for about 15 minutes, and then shut it off and let the acid off gas. And then they take that solution, they add water to it, and they call it good. And they preserve it a little bit. And some companies don't even preserve it. That's pretty much the process that everybody else in this industry uses. Now, if you go back to that image, Dory, that you were just showing, we'll hit on what parts of Christina's process look like. So you can see that we use the raw mineral from a mine that holds certifications and designation forms to be organic materials and all this CAS certification. It's clean and it's really good and it's organic. It's funny that they can say that our raw mineral is organic. I would hope so. But what you see in the fourth paragraph is what's really important. Above the FDA registered and inspected CGMP manufacturing facility, which is also kind of important. But the outline of what she works with and what she's created, when the above mentioned zeolite is processed for use as an ingredient, it's put through a patent pending process that includes thermal shock with pasteurization, food grade acidic treatment, sonication, filtration, secondary pasteurization, and additional ingredients added, and then a proprietary magnetic polarization process. No one's ever done this before. No one has a paragraph that reads like that with any other zeolite product in the industry. And this is what separates this, because of what she's doing to process it, break it apart, and add the trace minerals and the ascorbic acid. She's creating a completely different structure. This new combination that is patent pending. One of the patents was issued on it, and she's got more that she's done. So you can go from there.
Let's go back one slide, because I saw Verena had a question about 66.7%
Silica.
And then she wanted to know what the rest of it, 67%, and what's the rest?
So you can see the aluminum, the aluminosilicate, and then you have the calcium, the magnesium, and sodium oxides. So that's where the sodium aluminosilicate comes in, along with the silica. So you have the calcium, magnesium, sodium right in the middle, right under the typical chemical analysis. So 1.3, 0.27, 1.8. And then you have a little potassium, the 3.42%. Then you have the aluminum at 11.4, because it's the sodium aluminosilicate. And then you have the 66% silica. So massive amount of bioavailable silica, along with that sodium alumino structure. Does this mean there are many more binding sites as there are more clinofragments in 1 mil? Yes. Yeah, so that's one of the, Verena asked a really good question about, the more fragments you have, the more surface area, the more binding capability you have, right? And that's the most important the most important component, if you're comparing products side by side, and no one else has actually tried to compare this, right? I didn't pay to have this done competitively. This was someone that was a customer that was doing the analysis for her own personal consumption. And this is what her data showed. But it's funny, with all of these other companies, with all these other products being in the market for a long time, no one's actually done the analysis to show what their fragment range is and to show the concentration. Volume is everything, not just the number of drops, right? Because we know Clean Slate, if you start with one drop, people are finding out this stuff's kind of powerful. Why is that? Because it's highly concentrated. Other products, you might honestly have to take a bottle of another company's products to get the amount of fragments that you might get in 10 drops of Clean Slate. And you're not going to get the same range. You're not going to get the polarization. You're not going to get the value.
Well, and not only that, I mean, now that you've added the minerals to it, people are only needing to take, 1 or 2 drops.
Yeah. And guess what happened? And see, but this is an important part of the conversation, right? People are taking 1 or 2 drops. But what's the primary constituency of the Clino that we're using? It's silica, right? So we don't just want people using Clean Slate from the detox process. By taking that 10 drops, you're also getting, or 5 or 10. And this is the part where you should kind of bump up and eventually try to increase, because you're not just getting the detox benefits, you're getting all of this bioavailable silica. That is where the regeneration process comes in, right? Of cells and red blood cells. So this is, I think this was taken a couple hours after someone was vaccinated. This is their live blood. See, it's already coined. But you see these little dudes swimming around? Those might not be your friends. But notice you don't see the red blood cells all spaced out like we saw on the right side image. They're all coined here. They're all clumped together. That's clotting. That's where embolisms and thrombosis and strokes come from.
And that's where you could take the D-dimer test to see whether your blood is clotted.
That's why you want to take a D-dimer test, because it's going to show this.
Yeah.
Only on Tuesdays with Dory do you get this level. So what makes this unique is what Christina's done to take the fragments and break them up into much smaller sizes and make them more bioavailable, make them stronger energetically, which is where the communication part comes in. Adding the trace minerals, adding the vitamin C allows for improved permeability, which allows for this clinoptilolite component to be more effective. So here's the key to every question you're going to ask about every disease. And Dory's done a phenomenal job of proving this with the initial compendium she put together, and God knows how many hours and how many zero-in she took to do this initially.
Oh, no, we didn't even have 0-in back then.
Oh, so you just busted it out because you just took the time because you don't sleep. And virtually every chronic degenerative disease is linked back to heavy metals and environmental toxins. So you know what the cause is. So as you start to remove that, you start to create a healthier environment. Does a healthy body have disease? No, it does not. It is not possible. A healthy system is just that. It's healthy. And if you want a good example, look at Dory, look at Claire, look at them now versus what they looked like a year ago. They were healthy before, now they're freaking outstanding.
Well,
Dory's hair is so good right now. Kiss and many bands from the 80s are like, hold on, I would kill to have that high quality of hair right now. Bon Jovi just sent me a message. He's like, I would kill for that coif. So you have to understand that a healthy system is healthy. A healthy system is not sick, right? It is going to function differently. But if you're really polluted, which causes the symptoms, and eventually, if you go see a practitioner, a diagnosis of an issue based on the type of symptoms you have, the process of cleaning things up and regenerating and restoring, almost like I use restore strategically. that it is not one thing you do, right? There's a combination, there's a trinity of things that you should do that allow your body to start regenerating. And it's not something that takes place overnight. But do we know it starts to happen really quickly? Yes, because Dr. Stefan Rao proved that. He dropped his biological age by 30 years in 15 minutes. That is statistically significant. So just remember that.
You want to take some questions real quick?
Absolutely. I'm going through some of them.
Because, Nancy has this interesting question about the 10 drops.
Okay, there we go. Would you explain the need to build up the intake of Clean Slate of 1 drop twice a day? Purpose of 2-week wait for 0N. I wouldn't wait. Some people talk about using Clean Slate to clean up your system a little bit to allow 0N to work better. Me personally, I wouldn't wait. Just hit them both. Because 0N is going to work better as your gut becomes even more efficient, but 0N itself is actually somewhat gut regenerative. So I personally wouldn't wait. Some people are different. The reason that we talk about titrating up is actually because of the community. We've had a massive amount of feedback from people that, now granted, when you read the label, it says 10 drops in the morning. 10 drops is a standard dose. That doesn't mean 10 drops is good for everyone initially, because it's so concentrated. As we looked at the imagery, this is more concentrated than anything else that's ever been put on the market.
I'm going to go ahead and end the call because it's already over an hour and a half on this call. So thank you everyone for joining us, and we will see you next week, same time, same place. And let's see, put this on, and we can all say goodbye. Goodbye.
Bye.
Thank you so much. All the best. Have a nice day. Bye.
Bye.
Awesome.
Bye.
Bye-bye.
Thank you so much for all the information.
Bye-bye.
Amazing. Bye-bye.
Bye-bye.
Konnichiwa.